Hello everyone. The title of this video is Graphing Transformations of Exponential Functions. So in this video, I'm going to be doing examples that are taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 6.2, called Graphs of Exponential Functions. And I'm under the heading Graphing Transformations of Exponential Functions. And each example I'm going to do is either an example from the reading, or one of the try it problems from the reading, or one of the exercises at the end of the section that's related to this particular objective. Alright, so in the last video, and earlier in this particular section, you saw the graphs of the parent exponential function, the basic one, f of x equals b to the x power. So this is going to take those parent functions, and you're going to perform some sort of transformation, whether it be a vertical or horizontal shift, vertical or horizontal stretch or compression, maybe a reflection across the x-axis or y-axis. Now, I'm going to be assuming that you have studied your function transformations in chapter 3 of this text, and perhaps have seen my videos on those things in chapter 3 of this text. So if you recall, right, this text here, I'll pull up the table of contents. Back to chapter 3 on functions, right, you had transformations of functions in section 3.5. So I'm going to be assuming you remember that stuff. And just get into this. Okay, so my first example, and for the first several examples, I'm asked to do the following. Write the equation for the function described, give the horizontal asymptote, the domain, and the range for the function. And we'll also look at the graph in Desmos at desmos.com, free online graphing calculator, when we're finished writing these out. So here we're given f of x equals, e to the x. Now I'll just start off with y equals e to the x, so I don't have to keep writing f of x all the time. And this is a basic, parent exponential function where it's just a base to the x power. Remember e. Remember e is about 2.7. That's really all I expect you to remember about e right now. So just know that this is a number bigger than 1. So the graph, the way it looks right now, is an exponential growth, right? An increasing function. But then we're asked to change the equation a bit, right? Transform this. So first, it's vertically stretched by a factor of 2. So remember, vertically stretching by a factor of 2 simply meant take the expression the way it was and multiply by 2. So now we have, y equals 2 times e to the x, right? This is the vertical stretch by a factor of 2. Then we're asked to reflect across the y-axis. Now remember, reflecting across the y-axis, going back and forth across the y-axis, that's a horizontal transformation. And whenever you are performing a horizontal transformation, you're just replacing the x's, you're just replacing the inputs. And to cause a reflection across the y-axis, you replace x with the opposite of x. Alright, so I'll do this. Here's a reflect across the y-axis. So it'd just be y equals 2 times e. You take the previous expression and just replace all the x's with the opposite of x. So now it's this, y equals 2 times e to the opposite of x. And then finally, shift up 4 units, up. So it's another vertical transformation. Remember the vertical stuff, you leave the expression the way it was and then do something outside of it. So then if I take this and shift up 4 units, I'll just say shift up, you just leave the expression the way it was, so y equals 2 times e to the negative x, and then just simply add 4. Right, plus 4 would move the graph up. And this is our final version of the function we're asked to graph. Now let's take a look at this. Well, I'm going to go through all the steps in Desmos, right, just to make sure that what they described is actually happening. All right, so back to that, the website's here, desmos.com, free online graphing calculator. So like I said, I'm starting off with y equals e to the x power. So you see this function here. And remember those basic parent exponential functions, the horizontal asymptote is the x-axis, right? The graph is approaching. It looks like it's touching it, but if you zoom in close enough, the graph is not actually touching the x-axis ever, right? And it's got a y-intercept of 0, 1, and it's an increasing function. The domain is all real numbers. The range is all positive numbers. Now, when I do that shift up 4 units at the end, that's going to move everything up 4 units. So the asymptote will move up 4, and that means the range is going to change, right? And that's really the only time the range will change is when I perform some sort of vertical transformation, whether it be a vertical reflection or a vertical shift up and down. Alright, so in the next function, right, they said do a vertical stretch by a factor of 2, right? So move all the points twice as far away from the x-axis, right? This is multiplying by 2, 2 times e to the x. And you see now on the blue graph, the y-intercept was 0, 1. And on this new graph, the green graph here, the y-intercept is 0, 2. That's twice the distance from the x-axis, a vertical stretch by a factor of 2. And the same thing happened for all the points. Alright, so now I'll turn the first one off. Now we're looking at this. Alright, then we were asked, right, to reflect this graph across the y-axis. And that was by replacing x with negative x. Y equals 2 times e to the negative x. Right? Now, do you see the reflection? I hope you do. Across the y-axis. So now I turn this off, and then the shift up 4. Right? Y equals the previous line. Y equals 2 times e to the negative x, and then I added 4. And you see how that just this black graph up here, or whatever color you're seeing, it's just everything on the purple graph moved up 4. So you see this had a y-intercept of 0, 2. This has a y-intercept of 0, 6. Right? Everything got shoved up 4. And even the asymptote. See how the asymptote for the purple graph was the x-axis. Move that up 4, and now it's the line, and I'll put this in here, y equals 4. And I'll make it like a dashed line because it's not really supposed to be there. And you see the asymptote is now y equals 4. The graph gets closer and closer to y equals 4 as you move to the right here. It doesn't actually touch it, right? Again, you can zoom in really, really close and see that the graph that we want, the graph we drew, or the graph they drew, doesn't actually touch y equals 4. Y equals 4 is a horizontal asymptote, right? But the domain is the same, right? Alright, so let me turn the purple graph off. The domain is the same, it's all real numbers, and the domain is all real numbers for any exponential function. It's the range that changed, right? Instead of being all positive numbers, now it's all the numbers greater than 4, right? Because everything got moved up 4. The graph will never touch below y equals 4, or never touch y equals 4, So I'm going to write all that in. So again, I'll make a quick sketch of a graph here. All right, here was, say, y equals 4. I'll make it, this is very tiny, I apologize, but here's y equals 4, like this dashed line here. And it had the point 0.06 on it, and it was it was going down from left to right like this, but never actually touching y equals 4. Right? So it was something that looked like that, right, after all the transformations were done. So the domain, I said it already, but the domain for any exponential function is all real numbers, right? Everything from negative infinity to infinity can be plugged in for x here. It's the range that got changed, right? The range, everything got bumped up 4, so instead of the range being all positive numbers, the range is now all numbers, greater than 4. So from 4 to infinity, right? Not including 4 though. Right? The graph does not touch y equals 4. And that's the asymptote. Right? The horizontal asymptote is now the line y equals 4. And this is all the stuff they asked for. What's the final function look like? Domain, range, and asymptote. And you can make a quick sketch of the graph too. Again, I'm just going to go to Desmos and show you. But if you want to make a quick sketch by hand, there's nothing wrong with that either. All right, let's do the same thing. Next example. Okay, so again, we're starting with f of x equals e to the x, and then doing the following. Right, so the first thing we do is vertical compression. Now, a vertical compression, that will move all the points closer to the x-axis, squeeze them toward the x-axis. So I'm going to be multiplying by something less than 1, which here they're telling me by a factor of 1/3. So we got y equals, instead of e to the x, 1/3 times e to the x. That's going to cause a vertical compression. Right, and you'll see the points on this new graph when I draw it, or write it up in Desmos. The points on this graph will be closer to the x-axis than the points on this graph. Right? You'll have a vertical compression. Then reflected across the x-axis. Now this is across the x-axis, not the y-axis. Now reflecting across the x-axis is a vertical motion, right? And so to reflect across the x-axis, you simply take the previous rule and multiply it by -1. So we have y equals -1/3 times e to the x. And then finally, shift it down 2 units. Just take the previous and move it down, right? So shift down 2 units. I'll just say shift down. Our final function is y equals -1/3 e to the x, and then -2 afterwards would shift it down 2 units. Right? All right, and let's see what this looks like. And going back to the Desmos site, so we're starting with y equals e to the x again. All right, domain all real numbers, range all positive numbers, and the asymptote's the x-axis. But of course, that's going to change when we move everything down 2 at the end. All right, so the first transformation was a vertical compression by a factor of 1/3. Now they might also say a vertical compression by a factor of 3. Just understand that when they say compression, you should be multiplying by a number less than 1. So if they say compression by a factor of 3, that means you're multiplying by 1/3, right? The reciprocal. So 1/3 e to the x. Let me make this a different color, because they're both blue right now. Make it red. All right, so the red graph is the new graph, and like I said, you have a compression by a factor of 1/3 vertically. So you see how all the points on the red graph are closer to the x-axis, squeezed closer to the x-axis than the points on the original graph. And the original graph had 0, 1 as the y-intercept. This one has 0, 1/3. It says 0.333, but it's 1/3. Alright, so now we're working with this one. Then we were asked to reflect this across the x-axis. Now this will change the range, multiplying everything by -1, so -1/3 times e to the x. And now you see the green graph pop up. Again, whatever color you're seeing, but the asymptote's the same. The graph still isn't touching the x-axis, right? I know it looks like it's touching the x-axis, but if you zoom in close enough, it's not. Now, instead of the domain being all positive numbers, instead of the range being all positive numbers, for this graph, the range is all negative numbers. Right? Only negative numbers are the outputs. Everything below 0. And then we shifted everything down 2. Right? So y equals, that previous function, -1/3 e to the x, and then -2 after, and you see the graph just move down 2 units. And that shifted the asymptote as well. So now instead of the x-axis being the asymptote, now it's y equals -2. And I'll make this a dashed line again. And again, it looks like they're touching, but they're not. Right? You zoom in close enough, you'll see that these graphs are not touching. So there we go. All right, so I'll make again a very rough sketch by hand of this. Let's see, the y-intercept is at 0, -2 1/3. I'll make, and it's going down from left to right. I'll make a rough sketch by hand of this. So here's -2 on the y-axis. Right, you're going to have your horizontal asymptote there. And the graph had a y-intercept of -2 1/3, and it was doing this, right? Something like this, right? But not actually touching y equals -2. Okay, so the domain, and as I said in the first example, the domain for any exponential function, all real numbers. Right? You can plug in whatever you want for x. But the range changed, right? When I reflected across the x-axis, when I shoved everything down 2, that changes the range, right? So the range here is everything below -2, right? So again, you always go low to high when you're writing intervals. So this would be everything from -infinity up to -2, but not including -2 on the y-axis. Those are the outputs. And then as you see, the asymptote is y equals -2. And this is all they wanted. Right? Okay. Great. All right, so I'm again just continuing this. All right, so this time we're given not one of those basic functions, right? Because remember, the basic functions are b to the x power. This is a base to the -x. Now we could rewrite this as 2 to the x, right, using properties of exponents, but I'll just leave it this way. Right? And then we'll perform, the transformations described. Now remember, reflected about the y-axis means replace x with -x. So that'll make this positive x in the exponent, right? Reflect. So first I reflect across the y-axis, right? Replace x with -x, and we get y equals 1/2 to the -x. So 1/2 to the x. All right, now we're back to one of those basic exponential functions. And then compressed vertically by a factor of 1/5. Or they may say compressed by a factor of 5, but remember, if you're saying compressed, that means you're multiplying by a number less than 1. All right, so then vertically compressed, we need to multiply the whole thing by 1/5. Y equals 1/5 times, and then this half to the x. And that's it. Those are the only two transformations we're asked to perform. And once again, I'll put this up and we'll see that those things actually happen as I've written them. Alright, so clearing all these out. Alright, so we started with y equals 1/2 raised to the negative x power, which I said was like 2 to the x, right? You see it's a increasing function. And then we were asked to reflect this across the y-axis, so this became y equals 1/2 to the x. See the reflection across the y-axis? I'm hoping you see that. And then we were simply asked to vertically compress this by a factor of 1/5. Y equals 1/5 times 1/2 to the x. And now you see all the points on the green graph are closer to the x-axis than the points on the blue graph, right? So I had a vertical compression. All right. And again, I'll sketch this by hand here. You got the point 0, 1/5 is the y-intercept. It's a decreasing function. Domains all real numbers. I didn't reflect it across the x-axis. I didn't move it up or down. So the range is still, all positive numbers, just like your basic exponentials. And the x-axis is the horizontal asymptote here. So again, a quick sketch of this final graph. So there's, 1/5 for the y-intercept, and it was a decreasing function, and had the x-axis as an asymptote when it was approaching the x-axis to the right, but not actually touching it. And domain, all real numbers, right? Like for any exponential function. The range, all positive numbers, right? Everything above 0 is an output. And the asymptote is the x-axis, right? Y equals 0. And that's all they wanted from us. Alright, so I've got just one more of these with the descriptions, and then we got some other ones where we're actually graphing ourselves afterwards. Alright, so here we're starting with one of those basic parent exponential functions where I have a base to the x power. And this is a base bigger than 1, right? 1.68 to the x power. So if I were to graph this on its own, it would be an increasing function. And then we have a few, 4 transformations to perform. All right, so the first one is shift to the right. All right, shift right, 3 units. Now remember, when you shift right or left, that's a horizontal transformation, meaning you just take the rule and replace the x with something. All right, replace the x's with an expression. And to shift to the right 3 units, you replace x with x minus 3. So we have y equals 1.68 raised to the x minus 3 power. Right, that will shift the original graph to the right 3 units. Then we're stretched vertically by a factor of 2, so that's just multiplying everything by 2, right, the whole thing by 2. So we have this vertical stretch by a factor of 2. So 2 times this 1.68 to the x minus 3 power. Then reflected about the x-axis, that's just multiplying the whole thing by -1. Right, reflect over x-axis. So now we have y equals -2 times 1.68 to the x minus 3 power. And finally shifted downward 3 units, and that's just subtracting 3 afterwards. Right. So a shift down, and this will actually, the reflection across the x-axis and this shift downward will actually change the range. Right. So now we have y equals -2 times 1.68 to the x minus 3 power, and then minus 3 afterwards, right, to shift it down 3. And this is the final function, what it would look like after performing all those transformations. All right, and once again, go to Desmos and we'll see all these happening. All right, so I started with y equals 1.68 to the x, right, this increasing exponential function. Then we were asked to shift this to the right 3 units, right? So y equals 1.68, but not to the x power, it's to the x minus 3 power. Right? And do you see the black graph, right? Every point on that graph is just 3 units to the right of the point on the original graph. Right? This had 0, 1. This has 3, 1. Right? To the right 3. So still the same domain, range, and asymptote though, but now we're vertically stretching by a factor of 2, just multiplying this previous one by 2. And you know what, I'll just copy and paste this and put a 2 in front of it. Alright, and you see now this red graph, every point on the red graph, instead of 3, 1, it's at 3, 2. Alright, there it was. Every point on the red graph is now twice as far from the x-axis as the points on the black graph. And then a reflection across the x-axis. So I'm just taking this and putting a minus sign in front of it. Alright, that reflects it across the x-axis. Notice how the range has changed now. Now it's, instead of all positive numbers, now the range is all negative numbers. And then just taking this and throwing a minus 3 after it to shift it down 3. So I'm just copying and pasting it and throwing a minus 3 at the end, and see that new final graph is just the previous graph moved down 3. Alright. And the asymptote changed from the x-axis to y equals negative 3. And once again, I'll make a very rough sketch of this off to the side here. Here's negative 3 on the y-axis. That's where your asymptote's going to be. The y-intercept was negative 4 something, negative 3.422 I think, and it was doing this. It was going down as you move from left to right, but something like that. Very rough. So the domain, as I've been saying every example, right, the domain of every exponential function is all real numbers. The range, though, which you can see from the graph, is all the numbers less than negative 3. So that would be from negative infinity up to negative 3, right, but not including negative 3 if you were writing an interval. And the asymptote is y equals negative 3. Okay. Wonderful. Alright, now we're asked to graph some functions ourselves. So graph the given functions. So here's what I'm going to do. Alright, now I know it's easy to just plug in values, and after you plug in enough, hopefully you'll see a pattern and you can draw the rest of the pattern. But what I'm going to do, just for at least this first one, I'm going to start with one of those parent functions, right? One of those basic exponential functions. Well, that would be 0.75 to the x here. Right, now 0.75 is 3/4. But so I know what this looks like. All right, this looks like this. So this has this graph. It would have 0, 1, and it would be a decreasing function, right? 0.75. You'd have 1.75 and then -1 and then 1 1/3, 4/3 for the output. And the graph is looking like this. It's a decreasing function with the x-axis as an asymptote, and looks like that, right? Because the base is less than 1. All right. Now, to get this graph to look like this, I'm going to perform, one transformation at a time. Well, first is if I multiply the whole thing by 3, and if I take this to y equals 3 times 0.75 to the x, what does that cause? Right? That causes a vertical stretch by a factor of 3. I'll just say by factor 3. So now, instead of having 0, 1 as the y-intercept, it has 0, 3. And instead of having 1 and then 3/4, multiply that, that'd be 9/4 or 2.25 when you input 1. And -1, instead of 4/3, it'd be 4. Right, when you multiply that by 3, -1, so you have -1, 4, 1 and then 2 1/4, 0, 3. And the asymptote doesn't change. I didn't move it up or down. It's just all these points are now 3 times the distance that they originally were from the x-axis. So 0, 1 goes to 0, 3, right? 1 3/4 goes to 1 9/4. -1 4/3 goes to -1 4. Or maybe I should have put them on the same axis, but whatever. And then all I have to do now to get this function here to look like the one they want is -1. Right? We take the previous rule and then subtract 1. And what would that do? That would shift everything down 1 unit. So not only would all the points on the graph move, but also the asymptote. So instead of the asymptote being y equals 0, now it's y equals -1. And I'll make a little dotted line here. And instead of 0, 3, now we're at 0, 2. Instead of 1, 2.25, that'd be at 1, 1.25. And instead of -1, 4, you're at -1, 3. And the graph is not going to be approaching the x-axis. It's going to be approaching the line y equals -1. So more like that. Sorry about that. These are crappy hand drawings. The graph should look, but it gets closer and closer to the line y equals -1. All right, and in fact, let me just show you. We'll just go to the Desmos site again, and I'll just enter the function that we were given, and we'll see. All right, so this is y equals 3 times 0.75 to the x power, and then -1. And yes, and then I'll put in that y equals -1, and make it a dashed line or something. And you can see that y equals -1, is the horizontal asymptote here, not the x-axis. Right, and it's a decreasing function like I had, and you see that y-intercept is at 0, 2, just like I had on my hand drawing. It was just not great looking, that's all. Right? Yeah, this is a much cleaner looking picture here. Yeah. Okay, but our drawing's not terrible. Right? The drawing does what it does. It has a decreasing function. 0, 2 is the y-intercept. Asymptote's at -1. It has everything that the other graph had. It just doesn't look as good because I did it by hand and I didn't do it on graph paper. Right? I would recommend if you had graph paper on you, do it there. It might make it look a little cleaner. Okay, and that's what I'm going to do for pretty much the next few exercises. All right, the next two examples is start start with one of these basic parent exponential functions and then talk about what transformations would have to occur to get the function they want. Alright, so the next couple deal with a base of 2. So I got them on the same page here. So I have f of x equals, 2 to the negative x. So if I was to start with, and this time I'll draw them on the same axes. If I was to start with y equals just 2 to the x, right, the basic function. So that has 0, 1. 2 to the first is 2. 2 to the negative 1 is a half. Alright, and it had a domain, all real numbers, range, all positive numbers, and the x-axis was an asymptote, and it was an increasing function. Right? So there was 2 to the x there, right? The graph in my orange color. Now this one's a simple one-stepper. All I would need to do to transform this function into this function is replace x with negative x, and I've talked about this. When you replace all the x's in some rule with the opposite of x, that's a reflection across the y-axis. And that just takes all the x values of these points and moves them, makes them opposite. So instead of 1, 2, got negative 1, 2. 0, 1 would stay at 0, 1, and instead of negative 1 half, you'd have 1, 1 half. And I'll put this in green. Alright, and the same asymptote though, right? It didn't reflect across the x-axis. And here's y equals 2 to the negative x, and that's all they wanted. Right? So there's the graph. And let's compare this to the actual thing, right? Let's see how this hand drawing compares to the Desmos drawing, a nice graphing calculator drawing. So y equals 2 to the negative x power, and look at that. It's a decreasing exponential function. The y-intercept at 0, 1, you got negative 1, 2, you have 1, 1 half if you were to put some points up. X-axis is the asymptote. Looks exactly like my graph here, but maybe not exactly, but like it's got the same properties. Okay, next example. Dealing with another function that has a base of 2. So once again, I'll start with that y equals 2 to the x. Start with that parent basic exponential function, y equals 2 to the x. So again, I'll draw that here. So once again, you'd have 0, 1, 1, 2, negative 1, 1 half. Same picture I had up there, right, for y equals 2 to the x. And x-axis is the asymptote, right? And then again, another one-stepper here. To make this function, this basic one, look like the one that we want, I would simply have to replace x with x minus 2. And if you replace all the x's in some rule with x minus 2, that's going to cause a shift to the right 2 units. So instead of 0, 1, go to the right 2 units, you have 2, 1. Instead of 1, 2, that'll be at 3, 2. Right? Instead of negative 1, 1 half, it'll be 1, 1 half. Right? It's the same picture. Right? The shape didn't change. Just everything gets moved to the right 2 units. Same asymptote, right? I just moved it all, I just pushed it all to the right 2 units. Right? And let's see how this green graph I drew compares to the actual thing. Right, so leave the base of 2 here, and then in the power x minus 2, right? And look at that, right? It's got 0 1/4, 1 1 half, 2 1, 3 2, like on my picture, and it's an increasing function. Got a x-axis as an asymptote. Looks pretty good, in my opinion. Okay. And I just got one more of these. Now this next example is pretty simple, similar to example 5. So once again, you got y equals f of x equals 3 times a half to the x minus 2. And I got the basic one that I'm going to start with, right? The parent function is the y equals 1/2, the exponential function with a base of 1/2 to the x. And once again, I'll try to put all these on the same axes this time. So 1/2 to the x, that would have 0, 1, 1, 1/2, negative 1, 2, and be a decreasing function with the x-axis as an asymptote, right, like that. There's 1/2 to the x. Right? And then one step at a time, I'm going to perform transformations to make this look like this. The first thing I would want to do, I think, is the multiplication, right? Any vertical transformation, I like doing multiplication before addition. So times 3, y equals, I take the previous rule and multiply it by 3. And this is just going to cause a vertical stretch by a factor of 3. I'll just write vertical stretch. So all the y coordinates on these points get multiplied by 3. So instead of negative 1, 2, it'd be at negative 1, 6. Instead of 0, 1, it'll be at 0, 3 for the y-intercept. And instead of at 1, 1/2, it'll be at 1, 3/2, which is 1.5. But the horizontal asymptote is still going to be the same. Right, it's still going to be the x-axis. Sorry, I should have hit that point. See, bad hand drawings. So here's 3 times 1/2 to the x. That graph. But still the x-axis is the asymptote. But every point on this new graph should be 3 times as far away from the x-axis as the ones on the original graph. And then finally, to make this rule look like this one, I'd be subtracting 2 afterwards. And that'll cause a vertical shift, right, down 2 units. So that'll also change the asymptote. Instead of the x-axis being the asymptote, now it's going to be down 2 units. Right, y equals negative 2 is going to be the asymptote that the graph will approach. And it's just this green graph I have, everything down 2. So instead of negative 1, 6, we're at negative 1, 4. Instead of 0, 3, we're at 0, 1. And if I take 1.5 and subtract 2, I'm down to negative half, so 1 negative half here. And we get this graph, and let me do this in like a pink color. So here through the point 0, 1, and then through this point here, and then approaching the line y equals negative 2. Right, so there's that graph. And this is 3 times half to the x minus 2. This pinkish graph here, approaching the line y equals negative 2 as you move to the right. And again, I'll go to Desmos, we'll take a look, and you should double check your work always, and just make sure that the graph on Desmos looks similar to my pink graph here, and it should have the same points. So 3 times a half to the x, and then minus 2. And yeah, you see it's got 0, 1. It should have 1 negative half. It should have negative 2, 4. Right? You can kind of see that with the grid lines here. And then it approaches, y equals negative 2. The horizontal asymptote's at negative 2 now. And it looks pretty similar to what I had. So good. And those are just a few examples. Obviously, some other ones might come up where you're doing horizontal stretches, horizontal compressions, reflections across the x-axis, y-axis, vertical shifts, horizontal shifts, right? All sorts of stuff can happen. Just hoping that, seeing a few of these here helps you out a bit and, refresh your memory on transformations as well. All right, so now my final examples are the other way around, where instead of giving an equation, we give it, we write a graph. It's going to be the other way around, where I have a graph and I need to write an equation. All right. So the next example I want to do, example 9 in this video, is exercise 38 from the textbook. So let me go back to the text, scroll down to the exercises for this section, all the way down. Here we go. And exercise 38, there we go. Now it says, for the following exercises, each graph is a transformation of y equals 2 to the x. And we're asked to write an equation describing the transformation, right? What would be the equation for this graph if the parent function was y equals 2 to the x? All right. Okay, so notice here the horizontal asymptote is at y equals 1. Right, so that means at some point plus 1 was added, right? Because remember, adding something at the end is going to move the graph up and down and move those asymptotes. Also, y equals 2 to the x is an increasing function, but notice this is decreasing, so it had to have been reflected across the x-axis at some point. And yeah, and notice the y-intercept is at 0. All right, so you know what I'm going to do? I'm going to draw this out, and we'll play around with it. Kind of, reverse engineer the function, if you will. So it has, -2, 0 on it. It has 0, -3. And y equals 1 is the horizontal asymptote. And here's how the graph looked. It looks like this. So, and here's what I'm going to do. I'm going to kind of reverse this back into y equals 2 to the x, right? Remember, the parent function is y equals 2 to the x. So I'm going to kind of back this up until it looks like this, right? All right, so one thing I'll have to do is move it down 1. Right. So if I move all these points down 1, this will be, instead of 0, -2, 0, be -2, -1. This will be at 0, -4. And now, again, the y equals 0 will be the asymptote. So the graph looks like this now. Doing the same graph, move down 1. Right, this is just move it down 1. And we're just going to reverse all this when I'm finished, right? So I'm going to go back until I look like the parent function, and then we'll reverse everything. I hope that makes sense. All right, then to get it, remember how the graph of y equals 2 to the x looks. Right, it's an increasing function with 0, 1 on it, and 1, 2, and -1, 1/2, and all that. So I need it to be flipped across the x-axis. So now instead of -2, -1, be at -2, +1. And instead of at 0, -4, that'll be at 0, 4. Right, and the graph will still have the asymptote of y equals 0. So what I did to get this pink graph here is I reflect it across the x-axis. And we're going to reverse that when we go back. Alright, so this is getting closer. All I would need to do now is multiply by a quarter. Right, if I multiply everything by a quarter, instead of negative 2, 1, it'll be at negative 2, 1/4, and that's 2 to the negative 2. 2 to the negative 2 is 1/4. And then 0, 4 would become 0, 1, and we get our graph. And I'll just do it in black. I know black is going to be confusing, but there's 2 to the x. It has 0, 1 on it, negative 2 1/4. And what I did to get from pink to black here was I multiplied by a quarter. Alright, so now I'm going to reverse all this. Alright, now we're going to reverse all this to see what the graph of our, this was our final graph here, the orange graph. This is what I want the equation for. Right? So if I start with 2 to the x, to get to the pink graph, I'd have to multiply by 4, right? I'm reversing everything. Instead of multiplying by a quarter, now I go backwards, multiply by 4. So y equals 4 times 2 to the x. That'll give me this pink graph. Then what I do before that, I reflect it across the x-axis. So, flipping that over means multiply by negative 1. Right? Y equals negative 4 times 2 to the x. And then I just moved everything up 1 to get the graph they gave us initially. Right? So y equals negative 4 times 2 to the x, and then plus 1. This is the equation of the function we were given. Right? And let's see. I know that's a lot, but you gotta remember where we came from, go back to where you came from, and then kind of just reverse the process. Now let's see in Desmos. Alright, so I'm going to graph up in Desmos the function I ended up with here. Y equals negative 4 times 2 to the x, and then plus 1. And you see there's negative 2, 0. Here's 0, negative 3. And remember, you only need 2 points. You saw this in section 6.1. You only need 2 points to determine an exponential function. So if these 2 points are on it and it's decreasing, and look at the asymptotes at y equals 1, everything is the same as the graph they gave me. Everything is the same. So that is a valid function. All right. Wonderful. Alright, so I'm going to do that again. I know it's a process, it's a chore, but it's doable. Let's take it one step at a time. So let's do that again with exercise 40. Alright, my next example. I just got 2 more of these. Alright. So exercise 40, same thing. We're given some graph of an exponential function that's a transformation of y equals 2 to the x. Alright, and then once again, what I would like to do is I'm going to take this graph here. I'm going to go backwards 1 transformation at a time until I get the graph of y equals 2 to the x, and then we'll reverse those steps to get our equation. Alright. Now, I guess another thing you could do is the following. Nah, that's too much. I was thinking of something but that would cause, I don't want to do that, right? So I was thinking of something that probably would work, but that'd be too much for this video. Maybe not, I don't know. But let's just do the transformation stuff, because that's what this video is about, right? Graphing with transformations. All right, so again, I'm going to draw this up. The key points here, I'm going to pick 2 key points to make sure I know at least 2 points to define an exponential function here. We got 0, 1 is on this clearly, and 1, 2 is also on this. So is negative 1, negative 1. So I got a few points here, but 0, 1, 1, 2, maybe I'll throw negative 1, negative 1 on there as well. And the asymptotes at y equals 3. So once again, I'll draw this up. So 0, 1 is on it, 1, 2 is on it. The asymptote's at y equals 3. And same, and -1, -1 was also on it, but you really only need 2 points. And the graph looked like this. All right, it was approaching the line y equals 3. All right, so that's our final graph. All right, so I'll write final. This is the one we want the equation for. Remember, we want to get back to y equals 2 to the x, right, which has 0, again, 0, 1, 1, 2, -1, 1/2, and so on. Right, looking something like that. We want to get back to that. So again, same thing I did earlier. What I want to do is I'll get the asymptote to be the x-axis first. So I'm going to move everything down 3, and then after I perform all these steps, we'll reverse them, right, to get the final equation of this final graph. So I move everything down 3. So 0, 1 goes down 3 to 0, -2. 1, 2 goes down 3 to 1, -1, and then the asymptote's the x-axis now. And so now we have this graph. So that was down 3. And I'll write the stuff I'm doing here. And again, don't forget, at the end we're going to reverse this to get the equation of our final graph. So the first thing I did was move it down 3. Then what I would like to do is reflect across the x-axis. Alright, and that'll cause this to happen. 1, -1 will go to 1, 1. 0, -2 will go to 0, 2. And now I have this graph. The x-axis is the asymptote now. Right? Now I'm on the pink graph. Alright, and then not finally. Almost there. Now remember, the 2 to the x is an increasing function, so I need this I need to flip over the y-axis as well. Reflect across y-axis as well, and that'll take 1, 1 to -1, 1, and yeah, it's just going to flip it over here. Let's do this in dark green. So now it looks like this. And now I'm on this dark green graph. And that's really close. See, I got -1, 1, got 0, 2. If I just shift this to the right 1, you'll have 0, 1, and 1, 2. You'll have the same 2 points. So I'm just going to shift to the right 1, and we'll have our graph. But again, we're reversing all this at the end. So then we have 0, 1, and we have 1, 2. Let's just shift it over. Let me grab this color. And there's y equals 2 to the x. Right, it's got 0, 1, it's got 1, 2, an increasing function. X-axis is the asymptote. I know that was a lot. But now we reverse this. Right? So we're starting with y equals 2 to the x. The reverse of move it to the right 1 is move it to the left 1. So now we have y equals 2 to the x plus 1 power. Remember, replacing x with x plus 1 moves it left 1. So I got that reversed. And then reflect across the y-axis. To get the pink graph, that would replace x with -x. So 2 to the -x plus 1 power. That's across the y-axis. Reversing across the x-axis is going across the x-axis again. So multiplying this by -1. -2 to the -x plus 1. There's across the x-axis, reversing this, and then down 3. Right now I'm on this green graph. All right, down 3, just reversing is going up 3. So plus 3 after this. Y equals -2 to the -x plus 1, and then plus 3 after, and there you go, right? Up 3. That reverses the down 3. And the graph of this should be the graph that they gave us. And I know that was a lot, but let's check it out. All right. So back on Desmos, we have y equals negative, and then 2 raised to the negative x plus 1 power, and then plus 3. And look, there's 0, 1. Here's 1, 2. You got negative 1, negative 1, and it's increasing the asymptotes y equals 3. Looks exactly the same as the graph they had here. It's exactly the same. Alright, and again, I know it's a lot, but you got to know your transformations really well. Alright. Alright, now I just got one more of these. Alright, so now just find an exponential equation for the graph. So this one be a little easier. Okay, this one will be a little easier. Oh, you know what I could have done? Okay, wow, this would be a lot easier. Alright, so how about this? Alright, so I'm going to do this final method for this last example, and just know that this could have also worked for the first two. So the first two examples, example 9 and 10, exercise 38 and 40, I did all the transformations. I guess you could do it this shorter way. Alright, so look at exercise 42. So we're just asked to find an equation for the graph. So these aren't going to be 2 to the x. These aren't necessarily from 2 to the x anymore. So I don't even know what base and power they're from. Alright, so I need to figure that out. And again, we could have done this from the previous examples as well. Alright, so again, I'm going to draw this up. Exercise 42. And we're just asked to write an equation. Right? This isn't going to be starting from 2 to the x or anything. So remember, to write an equation, well, for our basic exponential function, right, f of x equals a times b to the x. Remember this, I only need 2 points. I just need 2 points. So first, though, this doesn't have an asymptote. This has the x-axis as an asymptote. So all I'm going to do is move the asymptote back to the x-axis. You'll see what I mean. So this has negative 1, 0 on it, and 0, negative 2, and the asymptote's at negative 4. Okay, and then we'll draw the rest of it in here. Alright, so drawing this in looked like this. And maybe I shouldn't be using this faded marker here, but had the asymptote at y equals negative 4. So again, the first thing I'm going to do is, I guess I could also leave it this way. Yeah, why not? I'm going to leave it this way and just know that, at some point I took an exponential function that had the x-axis as an asymptote and moved it down 4. So I'm just going to throw a minus 4 here, and we'll use the couple points we know to find a and b. Alright, find a and b. So I know the point negative 1, 0 is on this graph, and the point 0, negative 2. Okay. So output 0 equals a times b to the negative 1, minus 4. And then here, output negative 2 equals a times b to the 0, minus 4. Alright, I'll remember b to the 0, since b is not going to be 0 or negative. This is just 1. So from here, the second equation, we have a equals 2, because it's a times 1. Then I just add 4 to both sides. And then I pop this up here, use a equals 2, and we have this equation. 0 equals, 2 times b to the negative first minus 4. So b to the negative first is, 4 divided by 2 is also 2, meaning that b must be a half, right? Raise both sides to the negative first power. So I have a is 2, b is a half, and we get the following. F of x equals y equals, a is 2 times b is a half, right? 2 times half to the x minus 4. And there's the equation. Right? That's a way to do it. And we could have done this, I guess, in the first several exercises too, but I wanted the base to be 2. I guess you could have done this and then changed the base to be 2 with some properties of exponents in exercises 40 and 38. And then let's double check. When I plug in negative 1, this would be 2 times, a half to the negative 1 is 2. 4 minus 4 is 0. Negative 1, 0 is on the graph. Check. And when I plug in 0, you just end up with 2 minus 4, negative 2. So 0, negative 2 is on the graph. Also check. And then negative 4, because of this minus 4 here, right? This is the asymptote. And yeah, everything looks great. And if you really want to double check, right, go to Desmos, enter this, and see that it looks exactly the same as the function we were given. So that's what I'll do. So y equals 2 times a half to the x power and then minus 4. And there's your negative 1, 0. There's your 0, negative 2. Clearly the asymptote's at y equals negative 4. It looks exactly the way this graph does here. So yeah, like I said, I guess you could have done that for the previous 2 examples I had, and then just use properties of exponents to ensure that the base was 2. Great. And that's it. That's all I've got for you, these 11 examples here. A long video, I know, but it was broken into parts. You got using transformations to change the equation into another equation. Graph a function by starting with a basic parent exponential function and performing one transformation at a time. And then you had this last couple where you were given a graph and asked to find an equation for it, either using transformations or remembering that this concept here, you only need 2 points to find a basic exponential function, a times b to the x, and then you just add or subtract something based on where the asymptote is. You can do that too. Alright, I'm hoping that watching me go through these 11 examples here helps you out when you're graphing functions, exponential functions using transformations on your own. And thank you very much for watching.